Alright, now let's do a little bit of recap of what we did just now. Okay, we did this, right? Integration for this particular function in x with respect to x from a to b. A is what we call the lower limit. B is what we call the upper limit. Okay, there is a term for this whole thing. This is what we call definite integral. Make a good guess. Why is this called definite integral? Because there is a range from A to B. But previously, the kind of integration which you did is not called definite integral. Right? It's just integration by itself. So, if I were to summarize this result, this is what you get. After you integrate this, you will get big fx. Okay? And how do you apply the upper and lower limit? You substitute the upper limit and lower limit in respectively and get the corresponding result. Now, we're going to use a diagram for you to visualize better. How do I visualize this on the diagram? Okay, Kevin Tech, are you ready? The author is with you already. Any graph, let me call this fx. Alright? Any graph, okay, any curve, straight line whatsoever, if I want to represent this information over here, this is how it looks like. This is my value of A. Alright? Lower limit. This is my value of B. Upper limit. But what does this whole answer actually tell me? If I want to integrate fx from A to B and get the final answer, it's telling me, and it's as good as telling me to find the area under this curve with respect to x, the x-axis itself. Okay, so on a visual diagram, what integration is going to help you is find the area underneath the curve from the lower limit A to the upper limit B. Okay, bounded by the x-axis. How do I know it's the x-axis? Because I integrate with respect to x. Can you see A comes from here? B comes from here. Alright, where is the fx? The fx is this function over here and bounded by the x-axis. So I want this whole area bounded. Okay, this is what your answer is telling me. Okay? Clear cut? So make a very good guess. Now that we know this one, what do you think we also need to learn? Convert it to? What did I say? What did I say? No, it's telling you that the next topic we need to find this area underneath the curve. Okay? We are not going to do that today. Today I just show you how it looks like first. Okay? The area underneath the curve is also another big topic also. Why? 6 to 8 marks. Okay, minimum 6 to 8 marks for each question. But now, make use of the concept of definite integral. Okay? I want you to start thinking. What is this result going to give you? 0. Yes, what do you mean? 0. How can you know it's 0? Very good. You substitute A. You substitute A again. What is the outcome here? 0. And why is this 0? Make a very good guess. If I start from A, I end at A. Any area? It's just a straight line, right? Can I measure any area? So there's no area over here. So it's equal to 0. Okay, this is a very important result. Okay, this is important as well. There's another result you will need to know. What happens if I have this? Looks very cheap. Looks very complicated, right? Wow, how come got limit from A to B, then suddenly from B to C? But it's a very simple question, if you understand. Okay? This first part, is it exactly this one? Can you see it's exactly the same? What does the second part tell you? Where does the limit start from? It starts from B. So I continue from here. Can you see? There is a continuation. It's deliberate, huh? A to B, and from here B continues to C again. Alright, with the same curve function. So now, can you see if I want to continue from B to C, it just means that from B, I need to indicate another point C. So now, instead of finding the area over here, the first part tells you the area from A to B. The second part tells you the area from B to C. Can I summarize everything in one single expression? How do I do that, Wipeng? Thank you. Can you see that this whole area is just A to C? Lower limit is A, upper limit is C. This is another very important result. Okay, we're going to use of this result later. Last but not least, do you think these two results will be the same? Use your buttock and think a little bit. See why you smile with that buttock. So can your buttock think a bit? Do you think these two results will be the same? Kimberly, why not? Okay, because the lower and upper limit is different. One was from A to B. From A to B is this way, but from B to A is the other way. This is as good as telling me can these two expressions be the same? How do I make them the same? Thank you very much. You just have to introduce a negative 1. Am I right to say that? So long I introduce a negative 1, they will be connected. So similarly, the result that I will need you to remember is if the upper and lower limit swap, but the function that you're integrating is the same, you just need to introduce a negative sign. Okay, these are the three important results that I need to show you. And we are done for the day. Okay, I'm going to introduce two complicated ones. Okay, so what I need you to do is we're going to practice a few questions that make use of this logic. And at the same time, when I continue with the class tomorrow, if your friends did not view the video today, can you please help them with it? No. Okay, can you please help them with it? Okay, so that we can continue with the lesson itself. 可以吗? Can? Why is the weather so hot? It's because of the fan, right? No aircon. No, it's not no aircon. It's the fan and the weather itself. The weather is very, very humid, and the fan is not exactly spinning very fast. So by default, of course, it's going to be very warm. Okay, you will be wondering, how come Mr. Liu tell us these are important results? Why don't just go and integrate? Because there are some definite integral questions you cannot integrate at all. And we are going to take a look at those kind of questions now. Okay, you cannot integrate one because you have to make use of some known result. Okay, practice now 6. This is the result given to you. And I like this kind of question. Test a concept, then no need to crack your brain. Okay, because you smart talk also know how to do one. Because you really understand this concept. They do not tell you to integrate this. But they give you the result. If I were to integrate fx with respect to x from 1 to 4, they just tell you the answer is 5. You don't have to do integration. They give you the result. But based on this result, they want you to find out some other result. Take a look at the first one, part A. Let's use our backside to think. What are some of the things you may want to take note over here first before you can use the result? Yes, thank you. Aisha, what about the upper and lower limit? You need to swap. But you cannot anyhow swap. This is the given question. Can we change the question? We cannot change the question. I say again, this is the given question. We can't change the question. So the question has already been written. But we can make use of a known result. Let us write down the known result. Aisha, can I just write down this way? This one is equal to this one. Why not? Take note, there is a swap of the limit. You need to introduce the negative sign over here. Still not good enough. Thank you. There is a 2 over here. Do we need to continue with the 2 over here? Yes, we need to do so. Okay? So take note, the thing is in terms of the upper and lower limit, because there's a swap in terms of upper and lower limit, but yet I need to make use of the no result, I introduce the negative. Now, when we integrate fx from 1 to 4, we get 5, but there is an extra 2 over here. What do you think we can do to the 2? Yes, thank you. When we integrate or differentiate, okay, the number or rather an expression, do we need to be worried with the number? No need. So as such, if you no need to be affected by the number, you can bring out the 2 in front of the integral sign. Do I have the result for this one? It's 5. And then you have the final answer. If definite integral is given in this way, I'll be very happy. No need to do substitution at all. Can? Okay, you try the second one yourself. Same thing, whatever I've taught you, or whatever I've just listed, it will be put to you. If I integrate 2x like that, how do you do? 2x squared divided by 2, right? Correct? Do you need to do anything with the 2? No need. So if the 2 is always to be a number that you continue writing, can I write the 2 in front as well? So I can write this way, right? I integrate this one, this will still be x squared divided by 2 plus 2. Do I get the same result? is the same. Because it's a constant by itself, no matter you put it with the term or you put it outside the integral sign, you will still get the same result. Because the 2 will just be cut out. You don't have to do anything if it's a constant value. Okay?
Why you doing that?
Huh?
The plus.
Now what to do the plus 3? Okay, give me a while.
This picture is
Whoa.
How was the order?
Okay, whatever result I have shown you just now, you need to make use of all the known results. But what to do with the plus 3? That's a very good question. Okay, can we solve the question using the definite integral immediately? Cannot. We can only solve it when we have changed it to this form. Notice this integral is from 1 to 4, but this is from 1 to 3, so we cannot do anything. Okay, this one shelve it first. But the second one, okay, I need to bring you back to this concept again. If I were to integrate this, is it the same as integrating this one? Are we still integrating term by term? So can we adopt this concept into this question now? And the whole thing will be very simple. Can? Okay, is this a good thing? Okay, we adopt this concept of integrating term by term. But we seldom write it this way. Because why must we write this way when we can integrate just as a whole by itself? Okay, so rather than thinking this way, split it up. Okay, integrating term by term, and this is the concept that you need to make use over here. Okay, so I'll just continue from here. Now, is there anything I can do over here now? Yes, Kai Jie? Okay, use this particular relationship that we found out just now. Why do we say that? All take a look over here. Can you see the upper limit and the lower limit here is the same? And based on this graph, If this is the same function we are looking at, the upper limit is the same as the lower limit here, so it means that it's a common point. Instead of seeing this as 1 to 3 and 3 to 4, we can see this as integrating from 1 all the way to 4. So we combine everything together. So 3 is the common midpoint, 1 is your A and 4 is your C. So integrating from 1 to 4, fx dx. Do we have an answer for this particular definite integral? Yes, based on what is given. But do you know how to integrate 3? What do we get? 3x. Substitute these two values inside using your upper limit and lower limit. Okay? So definite integral, if it comes out, I'm telling you, I'll be very happy. But even if it comes out, it will not be a large amount of marks. 2 to 3 at most. 2 to 3 at most. I mean, how many questions can I give? Based on these results that I've just shown you, I can't give you too many. 2 to 3 at least, at most. Okay?